Hello all, I am Aslan, an independent researcher from Iran, and here I am happy to present my current work in motivation reinforcement learning, a study of social welfare and fairness under libertarian and utilitarian systems. During the conference meeting also, I would be happy to discuss further about this project. First, I am going to define some key terms. First of all, probably most of you are familiar with motivation reinforcement learning. Here, I'm going to emphasize on autocurricular. What I mean by autocurricular. Autocurricular refers to the inherent ability of motivation reinforcement learning to generate challenges, new challenges and new curriculum for agents because of the interaction between agents and between them and the environment, the changing environment. So natural challenges arise which these agents should adopt themselves. So autocurricular refers to this kind of happening, which is kind of relevant in motivation reinforcement learning setups, and it has four distinctive features. First, there are multiple groups. For example, each one of them composed of multiple agents. They compete or cooperate with each other, and the interaction of them generate challenges for different agents. And the agents they should adapt themselves during the training to these natural challenges. Second, the agent need to learn the high-level strategies, behavioral strategies, and not only learn the high-level behavioral strategy, but also the low-level implementation of them, composed of especially and temporarily extended sequential actions, low-level actions. So this is a kind of, again, relevant in motivation reinforcement learning setups. The third feature is that there are multiple strategies in the environment. I mean, some of the strategies are competitive, some of the strategies are cooperative, and there is they have also different levels of difficulty to implement them. So the agents, it is not obviously it is not obvious beforehand that which one of these strategies are going to be learned by the agents. And the fourth is that the representation of the agents, especially on temporally extended behaviors or strategies, are available for further inspection by the experimenter. For example, you have access to the internal structure of the deep neural network of the agent, and due to, for example, now widespread belief that there is a similarity between the internal representation of deep neural network and the internal representation of actual brain, human brain or primate brain. So this is also some other feature of these motivation reinforcement learning setups. The second kind of terms related to economy, and most part specifically mechanism design in economy. And basically, I believe that motivation reinforcement learning setups could be used to do in silico experimental economics, particularly for mechanism design. By mechanism in economics setting, in economics context, I mean, for example, here I brought three examples, which is going to be kind of clarify what I mean by mechanism design. For example, a government wants to design an efficient tax policy which imposes fair taxation on different sectors in the society without decreasing the productivity of individual firms. The government doesn't know that what is the fair rate of the tax, which is not going to affect adversely different sectors of the society. This is going to be determined only by a kind of, for example, mathematical modeling or experimenting in the society. So after doing this, the government would know that, for example, what's the best rate of the tax. But I believe that motivation reinforcement learning setup can provide an in silico setup to do this kind of, let's say, time-consuming and expensive process. Also, there are other examples. For example, the government decides to subsidize a particular product by imposing import or export taxation without affecting negatively the economic functions and social welfare in the society. And the third example, for example, the government decides to increase the price of gas to mitigate pollution or traffic congestion in large cities without affecting negatively various economic sectors in the society. This third example is so relevant to, for example, for Iran, because we have the government here has the power to set the tax, set the price of the gas, and also we have the problem with pollution and traffic congestion in the cities. So these are the key definitions. Now, the big questions of my project. These are the big questions which perplex me since, let's say, maybe 10, 15 years ago. And, I kind of pursuing this kind of big questions in different literature. And I am happy that finally I could find a unique, for example, research field which I could investigate these kind of questions. First, what is the origins of prosperity and poverty? Particularly for me, because I live in the West for a few years in Europe and US, and also I am now living in Iran. It is very important for me to know what are the causes and roots of this difference that you see in different societies. So there is one hypothesis which says that poor countries are not poor because of poor countries are poor because of their geographies or culture, or because, for example, the leaders of the countries, they don't know what policies they should follow, which good policy they should follow. This is one kind of, for example, one set of hypotheses regarding that why some countries are poor. The other set of hypotheses, which is kind of advocated by Acemoglu and colleagues, is that prosperity and poverty are determined by the incentives created by institutions, and politics determine what institutions a nation has. I am going to explain more about how I'm going to pursue this kind of big question with this environment, with this setup, with this multi-reinforcement learning setup. The second big question, which I am kind of interested in, that is that origins of inequality. By inequality here, I don't mean just something which can be measured by Gini coefficient or something like this. I mean the inequality of the agents, of the people in the society when they are facing the system. So how, for example, the system or the let's say the environment, if it behaves fairly with them or not. And this is what I mean by inequality. And this is relevant, for example, to what Thomas Piketty says in his book, that he's not concerned that much with, he considers that some kind of inequality is justified if it is founded only upon common utility. And also, this is somehow related to the Rawlsian principle of justice, universalization, and maximum principles, in which says that every agent in the society should have freedom to have access to the opportunities without, for example, any kind of restriction, and or without any kind of unlawful restriction. The people in the society should be equal in this regard. And the second is that any inequality is justified if it is in the advantage of the least advantageous person, in the favor of the least advantageous person. This is the maximum principle. For example, if there is an inequality in the society, what it is going to be in favor of, it's going to promote the least advantaged person in the society. That is again fair inequality. And the third kind of question, which I kind of follow during let's say a few years, is what is the origins of morality? I mean, how, for example, from the interaction of self-interested, selfish economic agents. I mean, it could be, for example, the agents in the society or the agents in the government or organizations. We can have cooperative, fair, or moral people. And again, by morality here, I am referring to more something similar to cooperativeness in opposite to the defection. So now, recently there is I'm going to explain one recent multi-agent reinforcement learning setup, which I'm going to modify this setup to investigate the questions which I mentioned before. This multi-agent reinforcement learning setup is called AI Economist. It is developed by Salesforce, and so it is originally designed for tax mechanism design. And one important feature of this multi-agent reinforcement learning setup is that it has a two-level order, which is very important for mechanism design. Because in mechanism design, we have two sets of agents, one central planner and the other set of agents which respond to the mechanism which is designed by the central planner. So in this setup, there are two material resources for gathering, trading, and building houses. There is one type of house, which is built by one unit of each one of these material resources, stone and wood. And then the agents are going to trade also these material resources, and the exchange medium that they use, it is coin. So there are many mobile agents with isoelastic coin minus labor as a reward function. And there is one central planner with various social welfare functions. Social welfare functions refer, for example, to productivity, to, for example, the central planner trying to increase the productivity in the society or trying to decrease the inequality in the society. Then also the other feature of this setup is that the final total taxes are going to evenly distributed among mobile agents. Then the table which I brought here, it shows that the agents are let's say three different they can do three different actions: move and gather, trade, and build. And the only differing factor among the agents is the build skill. Basically, the build skill is different among agents, and this is going to be to cause inequality in society in the subsequent, let's say, training epochs. Now, to investigate the questions which I mentioned before, I'm going to modify the setup. So the most important feature which I'm going to add to the setup is the tree governing system, which they have also voting mechanism. So a tree governing system which I'm going to introduce in this new setup with a voting mechanism. So full libertarian system, semi-libertarian system, full utilitarian system. Full libertarian system are the system in which the agent can vote on the resources, and it is the central planner is going to set the tax rate, but the agent can vote on the material resources, and after that, the agents are going themselves to invest they do taxes on the extraction or plantation of the material resources. The other thing which is also important is that instead of, for example, two type of material resources, I have three type: wood, iron, and stone. And also I have three type of houses, each one of them composed of 2 out of 3 material resources. For example, the green house is built based on 1 unit of iron and 1 unit of wood. So then there are three, as I said, there are three governing system. The full libertarian system, the central planner set the tax rate. The agents are going to rank the resources, and themselves is going to they themselves are going to invest on the material resources based on the ranking. In the semi-libertarian case, the central planner set the tax rate. Also, the agents are able to vote, but this time the central planner is going to count the votes using one of the vote counting methods, such as Buda method or majority method or plurality method. And at the end, based on the counted method, it's going to invest. The central planner is going to invest on the material resources, on the plantation or extraction of material resources. In the full utilitarian case, the central planner is going to set the tax rate, and also is going to rank the three material resources without considering any votes from the agents, and is going to invest the total taxes, total due taxes on the material resources, on the extraction or plantation of the material resources. As you see in the table, also the only differing factor among agents which is going to cause inequality in the society is the varied builder skills. Now let's come back to the first question. What is the origin of prosperity and poverty? So I believe, as I said, one hypothesis is that the geography is kind of conducive to this kind of different societies. For example, we have a poor society because of the geography, because of they lack the resourceful environment, or we have a prosperous society because they have a resourceful environment. So here, I guess it is possible with this experimental design. For example, in one hand, we are going to change the governing system. In the other side, we are going to change the environment. One environment is resourceful, has lots of, for example, is populated with lots of material resources, and the other environment is not resourceful. So I guess it is possible with this experimental setup to test this hypothesis. If the governing system is more effective for accumulated wealth among agents, or the environment is more effective to accumulate wealth among agents. Basically, this experimental setup is kind of a good fit to test this kind of hypothesis. Then the second kind of question is origins of inequality. So again, inequality, I mean, if the agents are equal in front of the system or in front of the, let's say, environment, or if the environment or the system treat them well, treat them fairly. So here, I am going to use a concept which is named, first of all, I am going to define a collisional game, and which is the collisional game should be super additive. And if it is super additive, there is one quantity or one metric which is called Shapley value, which is going to determine, this Shapley value is going to determine the average marginal contribution of each one of the agents to the grand collision. Grand collision is composed of all the agents. For example, in my case here, I define the collisional, at this moment, I define the collisional game using the voting and also the tax, using the vote and tax of the agents. And the grand collision is equal to the total tax. So the Shapley value is going to quantify if the due taxes of the agents are fair compared to the contribution that they have through the, for example, they vote and they work in the environment. The other thing which I can do possibly in the future is that, in the near future, is that I add the builder skill to this collisional game. I add here, the collisional game is defined only by tax and votes, but I think it is also interesting to add builder skill to this collisional game. So it could be a more fair comparison between the marginal contribution, contribution of the agents, between the average marginal contribution of the agents and the due taxes that they pay in each tax period. For origins of morality, there are again different kind of modeling framework to model morality. And here I use a kind of well-known formulation to model cooperativeness or fairness or morality in a society, which is called inequity aversion framework. Inequity aversion framework, the agents do not like to be treated unfairly regarding the other agents. For example, the agents do not like to be given more than the other agents, so they are advantageous inequity aversion, and which is characterized by beta coefficient, and the agents are not do not like to be given less than the other agents, which is going to be characterized by disadvantageous inequity aversion coefficient, which is named alpha. and there is a fairness space, every strategy in the multi-agent reinforcement learning environment can be mapped to one point in the fairness space, So again, the most important thing here is that how from the interaction of economic self-interested, let's say, rational agents, we are going to have a moral, fair, and cooperative agent. And I guess it is possible with this formulation, it is possible to quantify this. So here are some tentative results. Just I wanted to show that I wanted to show proof of concept of this framework. So these here we have 4 agents across episodes. I mean, the length of the episode is 1000. And if you check each one of these scores, you can see at most 6 colors. 3 colors refers to the material resources and 3 colors refers to the house types that they built. This plot shows the movement of the agents in this environment. They start from the red and they finish in the green. So these plots show the budget. Show, for example, how much wood, how much stone, how much iron, and how much coin they have in each one of those episodes, each one of those agents, and also how much labor they accumulate across episodes. These plots shows the trading of the agents. For example, in each episode, how much they sell or buy wood, or how much they sell or buy stone or iron. This shows the amount of coin that they exchange during this kind of trading. And this is the last set of plots related to the votes of the agents. Each one of the agent in this plot, each one of these plots shows that one agent, what is the vote of the one agent across the episodes. If for example, they are going to rank the material resources, the highest rank is going to be assigned as number 2, the second highest is going to be assigned as number 1, and the third position in the rank is going to be assigned number 0. So these plots shows that each one of the agents across episode, how they rank these 3 material resources. Now, possible future directions for this project. From the beginning of the project, I would kind of incline to say that there is somehow relation between this abstract representation of moral strategy in fairness space and action abstraction in reinforcement learning. So far, I couldn't come up with a kind of clean formulation, but this is something that I am still thinking to do in the future. So, and the second kind of investigation which I could follow possibly is that because I have access to the hidden state of the policy network of the agents, it is very interesting to find some kind of relation between this hidden state and the behavior of the agent. For example, one set of questions which is kind of interesting for me is that if I can determine if the agents vote sincerely or strategically, because the economic mechanism that I introduce here is not incentive compatible to reveal the true preferences of the agents. This is one set of questions. The second set of questions related to for example, what is the difference between the hidden state of the policy network of the poor compared to the policy network of the wealthy agent? And if there is some difference, can it be related to, for example, to the psychology of social economic status, such as risk averse, risk-seeking, short-sighted or far-sighted behaviors? Because we know, for example, the poor people are normally, they are risk averse and they are short-sighted compared to for example, a bit more wealthy people. So these are the set of questions which I can pursue in the following months. Thanks for your attention and looking forward to further discussion during the conference meeting.